make sure that we're live and also make sure that we're recording. Perfect. So, hey there, everybody. Thanks a million for joining us today. We're going to get to a very interesting session with David Simmons on Otterize. But just before that, I just wanted to go through a bit of house cleaning. That we have a few items that I wanted to mention, just to let you know that tomorrow is going to be the monthly Commissar community call. This is going to be a community call jam-packed full of a lot of information, since the tomorrow's Commissar release is going to be one of the biggest ones that we've put out. So if you can make it to the community call, I would definitely recommend it. We're also going to be naming the contributor of the month plus a new Commissar maintainer. So very exciting indeed. Also noteworthy that on the 17th of October, we are going to launch Commissar on Product Hunt. So keep your eyes peeled for that, and looking forward to your support. And that's pretty much it on my side. So for today's session, this is a virtual workshop like any other, in the sense that we're going to start off with a few questions so we can get to know our speaker and their background. We'll then move on to a hands-on demo to get to know the problem space and the tooling more in depth. And then after that, throughout, feel free to ask questions in the chat, and if it's fitting during the demo, but more than likely afterwards, we'll get to those questions. I have a few ready myself, and then if we have time, we'll do a game that I usually enjoy doing, and then we'll call it a day. So, without further ado, let's introduce today's speaker. So in today's session, we're going to be joined by David G. Simmons, Head of Developer Advocacy at Authorize, with expertise spanning time series databases, IoT, as well as many other topics that we'll explore today, with over 20 years of experience in software, having passed through many amazing companies like InfluxDB, QuestDB, Communda, and Startree. Rest assured that we're in really, really good hands today. He is really good at translating complex tech into understandable language, and we really thank him for that. And you can find him on X, formerly known as Twitter, at DavidGSIoT, and be sure to check him out there, since his feed is always super active and very, very informative. So, David, how's it going? Sorry if I missed anything, but yeah, in your own words, let us know about your background.
That was a great intro, actually. Thanks so much. Yes, I have been around for a very long time. I've been doing this forever, and yes, I'm old. But that was a good intro. I started off as an actual developer doing, hardcore developing on down in the network stack, in the TCP/IP stack, and have sort of moved through a whole bunch of different stuff. Mostly, I just kind of wandered into stuff by accident and ended up doing it for a long time, like IoT. I just kind of wandered into that, and I've been doing that for 20 years now. So it's not what I do now, but I like learning new stuff. So that's kind of what it's all been about. Is, ooh, that looks fun. Let's go do that for a while.
And what would you say interests you the most, like kind of professionally, in the tech space at the moment?
Really hard to say. I still have like IoT devices all over my desk, and I still do that. You can see that glowing orb up behind me. That's actually an IoT device, and I enabled my on the air sign as well, so I can turn those on and off remotely, and they do stupid tricks. But there's just so much going on in the tech space in so many areas. It's interesting to me that I'm with this job at Otterize, I'm doing Kubernetes, which it turns out is a lot of the same problems that I was working on back, almost 30 years ago in networking and network security space, which is what I started out doing, was doing networking and network security.
Yeah, how fitting! It's like a full circle. My career is much shorter, but yeah, that's how I also started out by getting a CCNA certificate and in routing and switching. So yeah, networking is always a cool topic to
We
rediscover.
can't do much without a network, right? It's what everything flows over the network, so you can't do much without it.
Exactly. And yeah, just for the people who may not think about networking that much on a day-to-day basis, I just wanted to kind of define a couple of terms just to kind of have them in our back pocket in relation to understanding Authorize a little bit better. So how would we define the difference between authentication and authorization when it comes to Authorize?
So what we're really talking about with Otterize and in the Kubernetes stack is not the kind of authorization and authentication that you or I do, right? When we sign into a service, right? Signing into a service, we authenticate as who we are, and then we get authorizations of what we're allowed to do, right? So those are two parts of it. And in this area, it's more of machine to machine communication. And so it's, how do these machines authenticate to one another, prove who they are, and what they're allowed to do, right? And unfortunately, what a lot of folks do in Kubernetes areas is they kind of punt all of that. And they build a cluster and they put a big fence around the cluster and let's hope nobody gets in, right? But if you do get in, then you have access to everything, right? And that's kind of what we're trying to prevent, is by adding authentication and authorization to services within the cluster, so that even if you do get in, you still have to have the right credentials and the right levels of authorization to do things within the cluster.
Perfect. Yeah, understood. And would definitions like zero trust, is that what we're talking about?
Yes. Basically, services don't trust anybody, right? I don't trust anybody. I'm a service running in a cluster and I don't trust anybody. You have to prove to me who you are and what you're allowed to do, right? And I try to talk to another service and they don't trust me either unless I can prove who I am and what I intend to do. One of the, actually, I want to go back to one thing, because we're talking about authorization and authorize. And one of the things that cracked me up about this company called Authorize is it's an Israeli company. And they named it Authorize because when an Israeli says authorize, it sounds like authorize.
Oh.
So I just thought, they had a really good sense of humor with that. And our logo is an otter. And I just think that's kind of cool, right?
Yeah, some people, and they wouldn't be wrong to think that we invited you on just because you also have an otter as a logo. We have a beaver. It's not necessarily in the logo. It's our mascot. But to be honest, you have more of a reason to have it. We just thought it was cute.
It is really cute, and I have a great time making stickers with our mascot, because otters are just so cute. So,
Exactly.
and if you find me at a conference, come find me, and I've got all kinds of cool stickers to hand out. So.
Amazing. No, I think when we do end up meeting at some stage, hopefully in person, we can exchange our beaver and otter stickers.
Absolutely, that'd be great.
For sure. So just quickly going back, also just to give context to people who potentially haven't struggled that much with networking issues or problems with networking automations, network engineers or Kubernetes administrators that have to interface with network policies, what kind of issues do they struggle with? What automations can help
So
them out?
network policies are, at least as far as I understand them, and I am going to be the first to tell you that I don't know much about them, right? But they are difficult and they are fragile, and it's a real pain to roll them out throughout an entire cluster. One of the things that I like about what I'm doing right now is that I can, and I'll show you this in the demo, I can do it and I don't have to know literally anything about network policies, and I can still end up doing zero trust in my cluster without actually knowing how it's implemented. And that's kind of the point, right? Is you shouldn't have to know everything in order to do these things. Now, back in 1992, which is a long time ago, in order to do basically what I was doing, which was zero trust, I had to write an entire version of UDP that was fully encrypted, which was not easy, right? You can encrypt stuff over TCP, but UDP is just kind of like fire a packet, and if it gets there, it gets there, and if it doesn't, it doesn't. But encrypting those packets, and then when it gets there, decrypting them is a whole different thing, or at least it was back then. So I had to like get really, really deep in the IP code to be able to do that. And nobody wants to do that, right? Because that's just too fragile, and it's hard to maintain, and it's hard to pass that knowledge on and keep doing that as you build out, right? And plus, more than one person needs to do this, right? So automating it is what computers do.
Yeah, and sometimes you might not really see the full perspective of the sentence. Kubernetes is complicated, and like we all know that it is, but no. Kubernetes is very, very, very complicated. There's so many different components. There's so many different moving parts, and I mean, you don't need to know every single part of how the cake is made to be able to be a good Kubernetes administrator. I mean, that's why it's the cloud native ecosystem, and just the amount of incredible add-ons and plugins that exist because there really is no time to wrap your head around every single nuance around Kubernetes, right?
Right. And one of the things that we're trying to do is make it easier for developers to do this, right? Let's say I'm developing a service that is deployed in a Kubernetes cluster. As the developer, I know what other services I need to talk to, and what other services need to talk to me, right? And so I shouldn't have to leave that up to the Kubernetes administrators, the security team, and all that. I should be able to define, here's my service, and here are all the connections it needs to make. And I can, sort of put those two together and have that roll out, right? And that's kind of that's what we're enabling with what we call intent-based. It's IBAC. And so you declare your intent. I have this service and I intend for it to talk to these things. And then Authorize can take those intents and turn them into actual policies, right? I just have to say what I intend to do. Authorize will turn it into policies, and I don't have to worry about it, right? And so I can write those alongside my code and not have to worry about the implementation, right?
Exactly. No, and yeah, like here at Tailwarden, that's exactly what we're about. I mean, even though the DevOps engineers, platform engineers, cloud engineers, or Kubernetes administrators can get a lot of benefit from tools like ours and yours, but if we can make life easier for developers themselves without having them take the CKA exam, like there's no badge to be worn. There's no badge that anyone really needs to say, hey, I'm a developer, but I'm also really good at Kubernetes.
Right.
You don't need.
And I understand everything about the cluster so that I can properly implement, certificate management in the cluster, because I have to do that because I wrote one service. What? No, don't do that.
Exactly. Like no one has time for that.
Yeah.
But yeah, perfect. And yeah, just I'm afraid that speaking about it too much will take away from the magic of actually learning as we go. So please feel free to unveil Otterize, and let's check it out.
Cool. I'm gonna have to move my camera off to the side here. So if I'm looking sideways, it's just so that we don't have the infinite recursion stuff with video cameras. So I'm going to start sharing my screen here. And I'm assuming you can all see that, right?
Perfect. There we go. Yeah.
So this is what we're talking about, right? And declare your intents, not your policies. And so I'm going to go through. I have built a cluster for this Tailwarden demo. Yes, it has low resource requests. I'm basically not doing anything with it, but I'm going to. So I'm going to go ahead and deploy a I'm going to create a namespace here for our ecom demo, which is a big application that does a whole bunch of different stuff. And then I'm going to go ahead and deploy all the parts of it.
Very nice.
So there's a whole bunch of different services, including a Redis cart and Kafka and all sorts of stuff, right? So it's not small. And now here comes the fun part. I'm going to go over to Authorize Cloud. I can do this other ways. There is just command line. But first, I'm going to go ahead and add a cluster. And we'll call it demo. And we'll call it our bite-sized. And I'll tell you why I'm calling it bite-sized. All right. So we'll use Authorize Cloud to do MTLS credentials. So MTLS is another one that's really a pain to do, right? It's deploying TLS certificates so that, but it's not just like on a web browser, it's basically one way, right? I don't have to have the certificate. You have the certificate and I get it. And I'm like, yeah, okay, that's a good one. In MTLS, we both have certificates and we both check each other's certificates, right? So I'm going to copy that. And then I'm going to deploy that. But I've actually got a couple of other things that I want to add to this because I want to be able to watch Kafka as well. So I'm going to add a Kafka watcher. Oh, no. I left the quote in there.
Oh, there we go.
So,
cool. So we're just to understand. So we're installing the Authorize Helm chart in the namespace that you've spun up. Cool.
Yes, in the cluster that I've spun up. Basically, it's going to have its own namespace, which is Authorize System, and so it's creating that namespace. Okay. I'm going to give it my cloud credentials, which I'm not worried about you seeing because I'll delete the cluster from our cloud soon. And I'm adding some other stuff here to provide certificates from Authorize Cloud. And I'm going to deploy the Kafka watcher. And here's the name of the Kafka that I'm going to be watching. So now if we go back here, you'll see that the network mapper is now connected and the credentials operator is connected. And it'll take a minute for it to sort of find stuff, but we should start to be able to see if we go and look at our cluster.
That's perfect. And that the GCP screen, we can see it perfectly. But whenever we head back over to the Otterize UI, if we could just increase it slightly,
Yes.
so slightly, perfect.
Oh, and look at that.
Oh.
We have things showing up. So this is our application, right? We've got a load generator talking to a front end. We've got a bunch of services. And right now, they're not quite all talking to each other. Kafka, nobody's talking to Kafka yet, right? So that'll take a minute to what we're doing now is our network mapper is listening to all the traffic in our cluster. And it's mapping who's talking to who, right? This is just actually a really useful thing to have regardless, right? Because oftentimes you're wondering, okay, so I'm deploying this, but what else is in my cluster and who's talking to who, right? And now I can see exactly what services are talking to what other services.
I'm sorry, if I'm not mistaken, the mapper can tell which services are speaking to which services at the moment due to the network policies that were generated by default, because we don't have any intents,
Nope,
do we?
not network policies. This is actually listening to traffic within the pod, right? eBPF traffic. It's saying what I'm seeing is this is talking to this. And if we click on these lines, so this one says that it's discovered that the front end calls ad service. Okay, so it's just discovered that there's no declared intents, and I can see that the yellow lines. So this, it says would be blocked. Load generator would be blocked from calling front end if we protected it, and the server, it says, is unprotected, right? So I can see what's going on in my cluster, and I can see what I need to do in order to protect it. Does that make sense?
A lot, yeah.
So let's see if anybody's talked to Kafka yet. Yes. So the checkout service is talking to Kafka, right? And these are stuff that we don't really care about. So let's go only look at the Authorize ecom demo namespace. There we go. That's a little better. Now, what do we want to do with this? Right now, we are not enforcing anything. We don't have any network policies deployed. We've got nothing, right? That's what we see here. But if we go and we do, let's say, Authorize network mapper, export the server, if I can type, front end dot authorize ecom demo. This will show me, remember, if I clicked here, it showed me the discovered intent that load generator calls front end. And here is that expressed in YAML, right? It's a client intent, load generator calls front end. So I can actually run that same command again. And pipe it straight to kube control. And if we go back here and watch our, oh, there it went. See that?
Yeah.
We have a green arrow, which means that client has declared its intent. It's discovered that this is the intent. Here's the declared one that I just declared and applied, right? And this client would be allowed to call front end if I protected front end, right? So now, since I have this green arrow, I could actually protect the front end service, and we would have basically zero trust between these two, right? I've declared that this is what I want to do. I have a network policy in place, and I can enforce that network policy. So let's see. I have a YAML file here for protecting the front end. And these are really simple YAML files, which is also kind of nice, right? I am going to declare that it's a protected service, that front end is the protected service, and that's all I have to do, right? So I'll apply that file. And if we go back and watch what happens, there it is. It's now protected, and it still works because I have a declared intent. So I declared my intention to do it. I put in place a network policy with that intent, and then I applied that. I started enforcing that network policy. And here's the cool thing that I can do is I can actually walk across this whole thing and start protecting services one at a time. One of the things that is really scary about deploying these kinds of things is that at some point you sort of feel like there's a big red switch that you have to throw, right? And am I going to break something? If I just deploy network policies through the whole thing and turn on enforcement, what's going to break? Well, I can kind of see now what's going to break. So let's go do ad service next. So instead of front end, we'll change this to ad service. And now this is a little different because you would think that, well, ad service is only being called by front end, right? As a service. But there's all these other intents named. And that's because front end calls all these other services. And so I want to declare all of those intents at once so that I don't overwrite them later. Does that make sense?
Yeah, yeah.
So now I can do that same thing.
But sorry, those intents were picked up automatically, right?
Yeah.
Because
Right. All I did was I said, who calls ad service? And it says, well, front end calls ad service. So let's go find out who else everybody else that front end calls. And we'll declare all those intents at once. And so the network mapper just exports those intents as a YAML file. And if I apply this, we go back to look at that. I have now declared network policies for all of these services, right? Now, here's a problem that I see. Front end calls product catalog services, but product catalog service is also called by recommendation service. So I can't just protect that yet, or this would be blocked, right? But let's stick with ad service for now, right? It's only got one line coming in. It's green. So let's turn that one green.
Sorry, I'm actually colorblind, so I thought the previous line was green.
Oh,
What was the previous color?
it's a sort of a yellowish orange.
Oh,
So if we apply that protect ad service, it will change from unprotected to protected. There it
perfect.
goes.
So nice. So literally only front end is allowed to communicate
Right.
with.
So if somebody came in and deployed a rogue pod here and tried to
Mhm,
call ad service, they wouldn't be allowed
mhm,
because they don't have the proper network policy.
mhm.
Now, notice I'm deploying network policies, right? Network policies are active per service protection, but I still don't know anything about network policies.
And you also don't know how big that network policy is getting, because
Right,
with so many apps in it that make up
right.
your microservice there, it will get really big, really complicated, and yeah, just the way that you're visualizing it here is just makes it so easy to debug, to know
It
what
does.
part of
It
it's
makes
working.
things a lot easier to, well, first of all, just here we go. Now we've got somewhere because now
Hmm.
we can see that all of these other services are actually calling Kafka, right? So I could protect recommendation service here because I see that it's already got a declared intent. So there's a network policy coming into it. So I have a recommendation service protection file. Basically just says protect it, right? And if I apply that file, we'll see recommendation service turn green because it will now be, currently it's unprotected. I just applied a protection to it and there it is. It's protected, right? So what I'm now doing, you can see, is I'm looking at all the services in my pod, in my cluster, and I'm going through them one at a time and making sure that they're protected and making sure that I don't break anything in doing so, right? So I can protect checkout service, right? Because it's got a green line coming into it. It's got no yellow line, nothing saying that it would be blocked coming into it. So I'll call the Authorize, if I can spell network, and I will export the intents from the server. And what was that server again? That was checkout service. Actually, I'm doing the wrong thing here. Let's just protect the checkout service. And we should see that turn green as and get listed as protected because I just applied protections to it. There was nothing wrong with it coming in. So, and there it is, it's protected. Now you'll see on the outside, it says would be blocked, right? So if I were to protect any of these services, checkout service would be blocked, my app would break, and I'd be hosed. And I'd be that person that broke production. And nobody wants to be that person, right? So I need to declare all of these network policies.
Hmm.
And I can do that in one fell swoop by basically picking anything that is called by checkout service. So let's choose payment service, and we'll do Authorize, network mapper, export, server, payment service dot. And we should see a bunch of network policies spit out, right? Those are all the services that come out of the checkout service, right? Here's the checkout service. These are all the things the checkout service. And if we give it a second, there we go. I've now got declared network policies for all of those. And I can start protecting them.
Yeah, and at no point there was any breakage, there was any miscommunication.
Right. So we can protect cart service. Now, I am going to show you what happens when you break something, just because I can, right?
Because hopefully this is not production.
Yeah, but you see this, that recommendation service, if I protect product catalog service, the recommendation service would be blocked because I don't have a network policy declared. So let's just see what happens if I do that. That was the product catalog service. I am now the person that broke production, right? Because recommendation service can no longer call the product catalog service because I didn't put in a network policy in place. So let's fix that really quick. What was this one called again? Product catalog service. You'll see that it said that 2 of them were unchanged, but it added one from the recommendation service. And now I'm green again, right? I'm good here. It's protected. I'm allowed. Production's back up. So this is one of the other nice things about this graph is I can see at a glance. I could see before I did that I was going to break it, right? And I did.
Yeah.
Okay, so don't do that. Use this as, let this be your guide so that you don't break stuff. And I can now protect all of these as well. The payment service, the currency service, the shipping service, and the order service. Because I've got network policies declared coming into them.
Would it be safe to say that a best practice for utilizing Otterize is intent first, protect second?
Absolutely. That is the way to go about it, because the intent basically says this is what I intend to do, and it creates the network policy, right? So now the network policy is in place. The protect is the actual enforcement of that policy. And if I turn on enforcement of network policies before I have network policies, then I'm enforcing stuff that doesn't exist and nothing can talk to anything, right?
Yeah, and just for someone who maybe like glazes over the documentation, would it be, and they only learn one thing from this, would it be safe to say that you can never break production by creating an intent? But you can the other way around,
Yes.
right?
You should not be able to break production by creating an intent,
Okay.
right? That's saying what I intend to do, right?
Yeah.
And it's declaring that. For some reason, my Kafka mapper is not working correctly because I must have deployed it. Oh, I know what I did. And I can fix that.
Nice.
So we're going to go way back in my history. There we go. I called it Kafka 0. And I should, I believe, just call it Kafka. The reason I'm changing this is that I have deployed Kafka with it spitting out a bunch of logs. And we can actually read those logs and not just see that payment service wants to call Kafka, right? That's pretty simplistic. But we can actually map which, what exactly payment service wants to do. Is it producing to a Kafka topic, and which Kafka topic is it producing to? And I can enable just that so that, payment service can produce to this Kafka topic, but it can't just randomly produce to other Kafka topics. It also can't read from random Kafka topics, right? So I can actually do these Kafka ACLs this way as well, which is really quite handy. But I deployed it wrong, and so we'll have to see if it manages to get itself figured out.
Great. Yeah, but that granularity is probably something that if you didn't have this, would be very, very just time consuming to
Oh my God,
configure
it's
yourself.
a nightmare. I can't even imagine having to do that. And now do I have a default to deny in Kafka? And now I have to go change all that. And how do I have to change my Kafka ACLs when I deploy a new service? Yeah, no, thank you.
Yeah.
I'm all set.
Yeah.
Right. So we could walk through this and protect basically everything here until we get to all green, which I'm sorry you can't see the colors. And I should probably make a note to go and do accessibility checks on it to make sure that people can actually see these things, right?
Oh, well, to be honest, I can actually see the difference. It's just that they both look green to me, but that's really just me.
So it may be a minute before the Kafka watcher is able to figure stuff out about what specific topics. But let's do currency service and shipping service. We'll do this currency service and shipping service. And currency service and shipping service are now protected, right? Kind of cool. And it turns out that we're also doing MTLS on all of this. So the MTLS certificates have been deployed as well. So what we're getting to here is zero trust, right?
Mm-hmm.
Not only do we have network policies in place so that only authorized services can talk to other authorized services, but it's all encrypted with MTLS. So if you happen to, again, this is, you build a fence around the cluster, but if somebody gets over the fence and they're in the cluster, they can do whatever they want. Not anymore, right? Not only can they not do what they want anymore, but they can't even snoop traffic to my currency service, right? Because it's encrypted.
Exactly. Yeah. It's
So
like
I'm getting myself to a zero trust cluster where even if somebody breaks in, they can't do anything.
it's like it's zero trust with zero the hassle, because going through each relation and each dependency between the pods is super straightforward in the super visual console. And of course, this we're talking about a hypothetical situation in which it's one developer that's in charge of this particular microservice. But I could totally imagine a much larger cluster with various teams, and of course, if you're enforcing a zero trust environment, each team member is going to have to talk to the other team member. Hey, by the way, can you allow this communication between this pod and that pod? And the hassle to enforce that zero trust is just huge.
Yes, exactly. And as a developer, I can say, recommendation service intends to call product catalog service. And so I can just create that intents file, right? I have some here. Right, if I'm developing the ad service, I can just create this intents file along with my code and put it into GitHub. And okay, there's a whole CI/CD pipeline, right? And as that CI/CD pipeline is rolled out, guess what? These get rolled out with it. You want the security team to weigh in and say, yeah, that's allowed. Well, now the security team can just go to GitHub as part of the pull request merge process and look at what the intents are and say, yeah, we'll allow that. That's okay, right?
That's perfect. That's incredible, because one thing that you mentioned before about breaking production, I was wondering, surely there's a way to apply the intents and to therefore create the network policies through Authorize with like in staging or in
Yes.
other environments, right? And surely there's a way that you can kind of work all this out before in a non-prod environment and then kind of like ship it in, and as you said there, that would be the way to do it.
Well, and you can see that I've actually been doing that, right? So had I been exporting all of these intents, instead of just sending them straight to kube control apply, but piping them out to a file, then I'd have this whole directory full of all my intents and all of my enforcements, right? And it works in production. And so I deploy all of those. It works in staging. So I deploy all of those when I push to production, and they all get applied, and production is now fully protected as well. And I was able to test it out in staging, and I have all my intents files, and I have all my enforcement files, and I'm ready to go, right?
Exactly. So you need not ever interface directly in prod unless you're into testing in production. So some people may like to do that, but you have like this non-prod playground where you can test things out, see how networking can be affected with the different intents, the different protections, and then once you're happy, boom,
right,
you just apply it.
And it's really quite simple to sort of apply these things, right? And if I get a new service, I don't even really have to know much, because I can go look. And in fact, that's how I created all of these protection files, is I had one, and then I just went and changed the names, right? From, so from ad service to payment service. Now I have the payment service file that will enforce the network policies that I've created, and I deploy that, and I'm all set, right?
Exactly.
And I can walk through this until, yeah, my Kafka mapper's broken, but I can do, I'm a terrible typist, which is why I have to look down at the keyboard.
No worries. I'm Not the best typing either. And anyway, we were talking about this right before jumping on that demos that don't go perfectly to plan are usually the most valuable ones. That's when we learn from troubleshooting.
So I'm just putting out the network intents for Kafka.
Very
And
nice.
now all the arrows going into Kafka are green, right? And I've got the email services, the only one I can now protect Kafka and email services, right? And Zookeeper. But now that I've got all of my arrows are green, which means that all of my network policies are correct, I can actually just apply enforcement across the board rather than going and doing it this way. So let's go back to here where we deployed the Authorize stuff. And back here where it says intents operator default shadow, we're going to change that to default active. And what that's going to do is it's just going to say everything's protected. I really hope you have your intents good because everything's protected. And if you don't, something's going to get blocked. So let's deploy that. And as that's deployed, we should see Kafka, Zookeeper, and email service turn protected. And there it is. I now have a zero trust cluster. Everything is protected by network policies that are enforced. And I'm good, right?
Exactly, yeah. Very,
Kind of
very
cool,
cool,
isn't
yeah.
it?
Yeah, no, very cool. And just that last step there of that kind of like across the board protection, again, saves a lot of time.
So we were calling this bite size because nobody wants to be the one that throws the big red switch and ends up with something getting broken, right? So yes, we're getting towards zero trust, but we allow you to sort of have zero trust in us at the same time by doing it one service at a time. I don't know whether this is going to work or not. So I'm going to just protect this service. Okay, then I'm going to just protect this service. And I'm going to work my way across my cluster one service at a time until I'm confident that, yes, this actually works the way it says it does. Okay, now I can just go and export all the intents from the whole cluster and apply them all. And then I can turn the enforcement on for the whole cluster and just be done, right? But I don't have to do that. That's the big red switch, right?
Yeah.
And I don't have to do that. I can do it a little bit at a time to make sure that everything's going to work the way I think it's going to. And I'm not going to break anything, right?
And this is something that the target audience, developers, understand perfectly, right? Because how is software created? It's created with incremental commits. If the commits are smaller, better. And that way you have a quick feedback loop to make sure nothing's breaking. And so the same way that you do incremental commits as a developer, this is kind of like incremental networking.
Yes.
Something that probably wasn't possible.
Well, and I can also, as a developer, I know now that I'm deploying into a cluster that has enforcement turned on. So I need to make sure that I have declared my intents before they get pushed to staging, because I know that enforcement is on. And if I haven't declared intents, then it'll get pushed to staging and it will immediately be blocked because enforcement is turned on and I didn't tell it what network policies to create.
Yeah.
Now, here's the cool thing. Do you know anything more about network policies in Kubernetes than when you started?
Not necessarily, no.
Not really, right? Yay! I don't either. And I don't have to go dig into how are network policies written and how are they enforced and how are they rolled out. I don't have to do that. I just have to look at my cluster and say, here's what I intend to do. Here are the network connections that I intend to have. And here are the ones that I want to protect. And I'm done.
Yeah. Yeah. I mean, what like you definitely want to give people knowledge, but
Mhm.
knowledge of what they want. I mean, what developers want is, does this work or not? And I think just from seeing this now through this demo, I think one of the main value uh, propositions that Otterize seems to have is that, sure, like we could do incremental networking, if we want to call it that, through very ever so slightly growing and adding to a network policy and trying it out. But the thing is, the feedback loop on that is huge. I mean, we would have to edit the network policy, apply it, then test it out by SSHing into the pod and then running a curl or something. Like, it takes a long time to make sure it's working. And the feedback loop that Authorize can give you is just instantaneous. I mean, if you're not colorblind, those lines will be able to tell you everything you need in no time.
So not, I mean, we sort of glossed over, this whole, the network mapper thing, right? In a sense, but I worked back in the 90s when I was doing all that network security work. I worked on networks that were very, very highly classified. Okay. It was where all sorts of nuclear weapons data was stored, very classified. And we had network maps, right? But they were basically on paper of what was connected to what. And we weren't entirely sure if that was accurate. And it turns out it wasn't. And I can tell you some horror stories about how we found that out, but it turns out it wasn't. And most network maps are that way. Pod cluster maps are the same way. You think you know what's in your cluster, but do you? Is there something in there that's talking that you don't know about? Well, now I know. And if I'm watching this and somebody adds a service, it will immediately show up on this map. Oh, there's a new service in town. Where'd that come from? Right? So now I actually have an always up-to-date map of what my cluster looks like and what the communication patterns are in that cluster, which is
Mm-hmm.
hugely valuable. And that's just kind of the gimme here, right? That's not even the whole point of all this. The whole point of all this is being able to protect it all. But the fact that I now know exactly what my cluster looks like and what every service is talking to and which other services are showing up here and those sorts of things is a really good thing to have.
It's huge because anyone who's tried to wrap their head around Kubernetes at the beginning. I mean, I remember when I was studying it for my first DevOps position. Sometimes I would just kind of close my eyes and just try to imagine. Okay, so what? Because the CLI, you can see each line. Okay, so in this, I know that there's a certain amount of pods, there's a certain amount of services, there's a certain amount of load balancers. But you would try to because everyone's quite visual, right? So you try to imagine the cluster in a visual way, and it's only really through tools initially K9s, Lens, others come to mind Argo CD. The UI for Argo CD is really, really great for visualizing the cluster. And now yeah, exactly. I mean, just this small kind of incremental step in visualizing, it's still in CLI form, but it's just much
Well, this tells me what pods I have, right?
exactly.
But it doesn't tell me who's talking to what.
That's right. Yeah.
And I still have to guess that, is email service talking to currency service? No idea. Absolutely no idea. Right? And K9s is not going to tell me that, right? I'm going to have to guess, or I'm going to have to, even worse, go back into the GitHub repository and look at the actual code. Ooh,
Yeah.
right? That can open up a whole bunch of stuff because it means that every developer has to have access to the code for every service. I can't even compartmentalize it, right?
Yeah, and if you do have an issue in your Kubernetes cluster, I mean, the first place that you're going to look is never going to be the network policy.
Right.
You know, like, I mean, that's down the line, because it's not that kind of intuitive that might be the issue. So the fact that you have this kind of like culmination of visibility through a much more visible diagram of what's actually in that namespace, plus the 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 network relationships. I mean, there's no guessing. I mean, if the line is broken, if the line is red, I mean, that's you know where the issue is.
I mean, I can even, this is my Google console, right?
Mm-hmm.
And I still can't tell what's talking to what, right? Yeah, here are the nodes,
Yeah.
right?
If you
Are there
go
any
to
logs?
observability, you're just going to see the health of the nodes. Yeah,
Yeah, but it's still not going to tell me, what's talking to what.
exactly.
So this kind of gives me a really good look into what's going on in my cluster and just what my cluster actually looks like in terms of communication patterns, right?
Yeah. Yeah, no, incredibly powerful. I had this question saved for after the demo, but like while we're here, I just wanted to quickly ask you. Um, Now that we're on the Authorize UI, what would be kind of like a potential like feature or functionality that isn't necessarily that apparent to the first time user that really is quite valuable in your estimation?
What was that again? I'm sorry.
What UI feature that initially probably isn't that doesn't stand out, but you find it to be quite useful? Maybe something that we haven't explored in the Authorize UI.
Well, unfortunately, my Kafka mapper does not seem to be functioning. I didn't deploy it correctly, but that's a
Mm-hmm.
hugely valuable thing to be able to say, like, what, not just, yeah, that's calling Kafka, but what topics is it producing to? What topics is it allowed to, read from, and being able to set very fine-grained ACLs on my Kafka implementation is huge, right?
Mm-hmm.
And I'm not quite sure how I broke that today, but I always break something. So today it's Kafka, right? That's it. Here's the other thing is that actually you can also generate this graph from the command line. It just doesn't look as cool.
Yeah, I can imagine.
Right? You can generate an actual image from this, but it just doesn't look as cool.
Mm-hmm.
So I always
Yeah.
go to the cloud because I like to be able to see it with, pretty colors and Bezier curved lines and all that stuff, right? And being able to watch it in real time as I add protections and define network policies and roll those out, right?
Mm-hmm. Yeah, no, I mean, just looking at it now, I understand. I would always go to the cloud also. Amazing.
And Amazon. So Amazon just announced their VPC CNI integration, right? So they have their own CNI. We work perfectly with that, right? You don't even have to change anything. You can use their CNI. You can use Istio. I mean, whatever you want to use as your network policy, mechanism. Pretty much, we can work with that in the same
Mm-hmm.
way. You don't have to change anything that you're doing that we did here, right?
Mm-hmm. Very, very interesting. Any upcoming features on the roadmap that?
Yes, we are. We do have some features coming up. We are working on some things like let's see, RDS and AMI, so that you can use those. We are also, I will say, participating in Hacktoberfest, which started this week. And our network mapper and our intents operator and our credentials operator are all open source, as is all of our documentation. And we would more than happily welcome contributions. So if people want to go and hack around with it and see what else they want to do and implement a feature or something, we're all about open source.
Perfect. Yeah, no, that was actually going to be my last question here about which would be the best way for contributors who are interested to get their hands dirty and to attack some of the open issues that I'm sure you have. So yeah, at the end of this, if you don't mind, maybe you can share those links and we'll add it to the YouTube video that we upload a little bit later on.
Cool.
Amazing. Yeah. But apart from that, would there be any other ways for contributors to get involved in the project?
Download it, play with it, use it. Submit issues, submit, feature requests, submit pull requests that fix issues or add features. Basically, if there's something that's not in here that you really need to roll out into production in your environment, let us know and we'll work on it. We are absolutely 100% customer driven. So if we have a customer that says, look, we want to roll this out into production, but it's missing this, well, okay, let's talk and we'll work on that so that we can get you into production with this. I saw all this and I was just kind of blown away by how easy it is to do this stuff in Kubernetes that is generally very hard, right?
Mm-hmm.
This turns rolling out MTLS and network policies from a project, right? We all know what a project is. You got to get, management involved. You got to get security involved. You've got to get, it's got a timeline, it's got a budget, and it's going to be 9 months of incremental work to get it rolled out. This is not a project anymore, right? This is, I can do this. We can roll this out next week, right? I can roll this out in my cluster next week and not break anything in production. Furthermore, right?
Yeah, and you don't need a huge security team to be sure that you're pretty well protected in your production environment.
I mean, I can now show that I've got, certificates deployed. I've got MTLS certificates deployed, and everything's protected, right? I've got network policies. Everything's good. And I can show that on every service. And this is what front end calls the cart service. And I've declared the same intent. So we're sure that's okay. And it's protected and we're all good. Right.
Incredible. So yeah, David, we just went over an hour. I want to be mindful of your time. This has been incredible.
Well, this is the end of the demo, so we can do whatever you want now. I have demoed all I have to demo. All my, my cluster's all green and zero trust cluster, and I'm all set.
Well, yeah, I mean, I had a few things planned out here, but to be honest, since you've already been generous enough with your time, maybe we can leave it for another one.
Sure.
But perfect. Yeah. So that was super clear. We got a really, really good insight into what issues that we can tackle now with Otterize without necessarily becoming network engineers. So really, really appreciate it. Is there anything else you want to share? Anything else apart from the Hacktoberfest?
No, we are actually, by the way, for people who are participating in Hacktoberfest on our projects, we are actually still going to send t-shirts this year. I know Hacktoberfest is not, but if you get, I think it's 3 pull requests merged in our repositories, we'll send you some swag.
Very nice. Worldwide?
Yep.
Nice. Nice. Very cool. That's a great incentive. So David, thanks again. It's been an absolute pleasure, and yeah, we'll be in touch. We'll see each other.
Yes, absolutely. Thanks so much. This was super fun. Had a great time.
Cool. Catch you next time.
Okay, bye.
Right. Bye bye.